In this lecture, we're going to talk about the laws of motion, that is also in chapter of class 9th. First law of motion. Now, first law of motion states that a body is said to be at rest or at uniform motion until or unless external force acts on it. Now, this law or this condition gives us the definition of the force. This condition or this law has two parts. First one is at rest. A body is at rest. And second one is a body is at uniform motion. A body is said to be at the position of rest when it does not change its position with respect to its surrounding. Just suppose a person is standing in a garden. If this person does not displace or does not move, it will called in rest. We will call that the body of the person is in rest until or unless another person pushes him and he will cover displacement. Now here external force is applied on the body and it displaces. As written or as the state of the first law, until or unless external force act on it. Now this is also relatable to the uniform motion. How a body when a body is in uniform motion, like sun is rotating, earth is rotating around the sun, moon is rotating around the earth, electron is rotating around the nucleus. Now these are the examples of uniform motion. Now when a body is in uniform motion, it will remain in uniform motion until or unless external force acts on it. Now there are some conditions that we can't say that the person who is standing in a garden is at rest. How? Because as we know, the earth is continuously rotating around the sun. So with respect to that point, this body is not at rest. But we're going to suppose that the things that are near to him, like trees or the pupil or the children playing, he is at rest with that reference. But when we talk about other points, we're going to say these are the relative motion, because in this kind of situation, any body in the whole universe is not at absolute rest. So we're going to state that situation or that condition as relative motion. Now here I have stated the first law of motion. Let's talk about second law of motion. When let me make a figure. Just suppose an unbalanced force, a random force is applied to a body, and this body covers displace or start acceleration or accelerates forward direction. The force is also in forward direction and it displaced in also forward direction. Now second law states this direction. Second law gives us the definition of the acceleration. Second law states that when a force is applied to a body, it accelerates. It produces a speed up. It accelerates forward direction in the same direction of the force. Now here acceleration is dependent on the force. Here's acceleration that is dependent on the force. If force in this direction, acceleration would also be in this direction. So we're going to say that acceleration is directly proportional to force. Now here the mass of the body also depends. Like if there is more mass, less acceleration would happen. If there is less mass, more acceleration would happen. So we're gonna say that acceleration is inversely proportional to mass. Now by combining these two equations, we're gonna have A is directly proportional to F divided by M. Now when we remove the proportionality sign, we got K. Now here the K constant does not have any value, so the constant that does not have any value is called temporary proportionality constants. Now we can mathematically also represent that. To represent it mathematically, we gonna say that F is equal to MA. In books, in PDFs, they are written that F is equal to MA, but that's the mathematical representation of that. That's not the actual equation. Actual equation is that acceleration is equal to K, that is not calculated yet, is equal to F and M. Now in MKS system, the unit of the force is kg meter per second square, that is equal to Newton. In CGS system, unit of force is dyne. Now 1 dyne is equal to 10 raised to power minus Newton. 1 Newton is equal to 10 raised to power 5. Now how we get that 10 raised to power something? So as we know that we are talking in CGS system, we know that 1 Newton is equal to kg meter per second square. Now here the kg is equal to gram. Now we know that kilo is equal to 1000. So we're gonna write it here 1000. M here meter is equal to centimeter. Now we know that 1 meter is equal to 100 centimeters divided by second square, gram dot centimeter. Now we're gonna have 1 0 0 0 0 1 2 3 4 and 5 zeros. Now in this way we got the value 10 raised to power minus 5 or 5. Now 1 Newton is equal to 10 raised to power 5. So 5 dyne. So when we gonna transfer dyne to here, it will be in inverse 10 raised to power 5. So that will become minus 5. Now in FPS system, it is equal to poundal. 1 poundal is equal to 0.138255 and 1 Newton is equal to 7.23301408014 poundals. Now the example of second law is cycling. We know that when we applied force to the pedals of the cycle, it accelerates and we are doing cycling in that condition. The hockey hitting the ball, when we just applied force on the ball, it accelerates, and that's all about the second law of motion. Third law of motion is very simple. To every action there is an equal reaction. Now here the book is applying force to the table and the table is applying force to the book. Now here both forces are equal. So we're gonna say that every action, book is applying action, work, and for table is also applying force. So he is also doing an action. So these both actions becomes equal but inverse in direction. So this is the third law of motion. And that's all about today's lecture.